All right, fantastic. Good afternoon, everybody. It's the finishing stretch here. Thanks for sticking around. So we're going to talk about energy storage today. I'm going to try to do that within 15 minutes. Energy storage by itself probably deserves a day as an introduction, but we'll see how far we can get within this 15 minutes. A quick intro to Lux Research. What we essentially do is we hire scientists and PhDs and engineers with some business experience, and we have them speak to all the innovators in any given space. So within energy storage, we've spoken to about 1,000 companies that are developing bleeding-edge technology that can revolutionize the energy storage world. So as you can see on this list, where did it go? As you can see here, there's a variety of coverage areas ranging from advanced materials to autonomous systems to sensors and so forth. So I'm based out of our Boston office. I did my undergrad just up the street at U of T, so it's great to be back in Toronto. And fundamentally, what we try to do is we advise our clients on which technology is ready for prime time, which are the ones to avoid, who are the best players to work with, and so forth. So I've broken out the presentation into three parts. First, there's a palpable sense of excitement around energy storage in 2016. And energy storage has been around for decades. Why now? Why is energy storage exciting now, and how real is it? Or is this just going to be another hype cycle? Number two, if we are excited about energy storage, what are the companies and technologies that are worth getting involved with? Who's currently got the best traction, and so forth? And number three, I thought I'd finish off with some perspectives for things to watch out for from the kind of mining side of things. So to start off with, there is absolutely an increasing concern around carbon emissions. So if we look at the transportation sector, the electricity generation, residential, commercial, and industrial, all of these different areas are under intense scrutiny to do something about carbon emissions. And so that is driving further interest into energy storage. More specifically, you can look at parts of Europe like Denmark, Sweden, Munich, that have set into motion plans to go towards 100% renewable. And you can't go towards 100% renewable without having some serious energy storage considerations. Closer to home, places like San Diego, Aspen, Hawaii, you see hot pockets of innovation, even in kind of today's very tumultuous debate around climate change and carbon. Nonetheless, there are regional hotspots of activity and innovation. And if we take a more systematic, data-driven look at what has actually been happening in terms of what is making up our power mix, we see that historically there has been a lot of coal and a lot of natural gas and nuclear that has been going into the new installs. This is for the US in gigawatts. And you can see over here it's by decades. So if it's above the zero line, it's a new install. If it's below the zero line, it's decommissioning. And you can see how pretty much the past 2 decades have been all about natural gas. But over the past 5-10 years, and increasingly looking out, you see this new emergence of renewables. So it's not just talk around, we want to get more renewables onto the grid. There's a lot of new installations that are coming onto the grid. And so far, because there's obviously a long lifespan associated with these, the penetration overall is not huge. But as this trend continues, we are going to start to get to high percent renewable penetration. Now, the other trend that's kind of been a little bit more subtle is you can talk about the generation as being centralized or distributed. So historically, a lot of it has been centralized. But what's really been happening over the past few years is that distributed generation has started to overtake centralized in terms of new installs. So you're talking about more renewable, more distributed, and this is giving that push towards more and more energy storage interest. So this is what that's actually meant for the industry as a whole. This is data where we have something called the Grid Storage Tracker, and we look all around the world, all the energy storage installations, whatever application it is, whatever technology it is. If it's an advanced energy storage project, we count it. And so you can see that this really started taking off just about 2009 or prior to that. And in our account, and this was last updated around the middle of 2016, we've crested more than 1,000 grid storage projects around the world. And those correspond to about 3 gigawatts in terms of power and about 4.7 gigawatt hours in terms of storage. So there's a couple of interesting trends here. You can see that the slope has actually increased over the past 2 years. So even though the project count rise has been a little bit more gradual over the past 2 years, people have been getting more and more serious about these projects. So it's not so much just, oh, we're going to try out some prototype. These are getting more significant in size as the technology gains more and more trust. Despite this initial promise, there's still a lot of questions. So there's no debate around the interest in energy storage. Of course, solar and wind have intermittency and dispatchability issues, and we need some sort of storage. But there are ongoing concerns about how real are falling costs and when will that come? What does that mean for payback? What does that mean for the resulting market size? And how does that vary by geography? So there's a lot of nuances and a lot of open questions around this, despite the excitement in the background. So in terms of a fully installed system, so it's not just the battery cells, but a fully installed systems with power electronic considerations, it's easy to still pay about $1,000 or more per kilowatt hour. So even for a relatively medium-sized battery pack, you're usually at $100,000 or more, which can have very detrimental effects on the overall project cost and the payback. So one of the key questions that we continue to track is, how real is battery cost decline, and what are the implications of that, and how does that tie into the kind of the feedback loop with enabling more and more solar penetration, more and more wind penetration? One of the most interesting kind of tangential notes here, and it's kind of easy to overlook this, but I really wanted to make the point here, is the humble 18650 cell. It's about the size of an AA battery, and it got its start in the consumer electronics business in laptops. And when Tesla was setting out to make an electric vehicle using technology that was available off the shelf, they bought thousands of these cells and stuffed it into a Tesla Model S. Well, first the Roadster, then the Tesla Model S. They are using the same technology to go into a stationary Powerwall. And if you're buying, megawatts worth of stationary storage, it's still that same humble cell, the 18650, that is making up all of this. Now, there's subtle differences. You might be talking about an NCA cathode chemistry in the car versus an NMC cathode chemistry in the stationary installation. But this is still the same factory and the same production line making these batteries. So when Tesla and Panasonic put their heads together to invest $5 billion into a brand new lithium-ion battery factory in Nevada called the Gigafactory, that is the world's biggest ever battery factory, that has as much implications for the cars as it does for the stationary storage projects. And one of the interesting things here is that this announcement, and this was about 1 or 2 years ago now, has kind of kicked the rest of the industry into a frenzy. So in China, in Europe, in other parts of the world, other battery makers and other OEMs are kind of matching Tesla's massive investments. So we're really starting to see massive levels of investment from very established players, and that has as much implications for the cars as it does for the topics that we're talking about today. And to give you a better feel for just how seriously the automotive industry is moving in this direction, I show here these logos over here are benchmarked to 2015, the number of plugins that are offered by each OEM. So you see that kind of around now, each OEM only offers about 1 or 2 plug-in vehicles to consumers. Look forward to 2020, and most of these companies are increasing the number of offerings by 2-3 times. So for example, Volkswagen, by 2020, they plan to offer more than 20 plug-in vehicles to consumers. Our view is that by 2040 and post-2040, the internal combustion engine is going to be on its way out. The automotive industry is firmly on the path to electrification, and that means that we're going to see a absolutely massive scale-up of lithium-ion battery production. And as I mentioned before, that has implications for not just vehicles, but also stationary applications. So this is interesting. So who's worth paying attention to? these slides will be available, but if you break out the energy storage landscape, it's a tremendously diverse set of choices. So you've got batteries for electrochemical storage, you've got fuel cells, you've got supercapacitors, you've got energy harvesting, and then other types of energy storage. And then within each of those, there's kind of additional subfamilies. And although I will say that each of these has their own pros and cons and interesting developers, the reality is that probably not all of these technologies will really succeed. These will not all be billion-dollar industries. So it's really important to get a gauge for which of these technologies are actually getting traction and promising in the near to medium term, and which ones might be relatively poor investments or poor bets to make. And so out of that same grid storage tracker, this shows the data not just by raw project count or raw deployment, but it splits it out into different technologies. So this is worldwide, and what you see here is the power, and here the energy side of things. So off to a really strong start all the way back to 2011 and before, we saw molten salt. These are relatively large batteries for utility scale installations, and Japan and NGK installators in particular were very strong early deployers. However, the story of growth has really been lithium-ion. You can see particularly on the power side, it has accounted for pretty much all of the growth in this industry over the past couple of years. So we're looking at compound annual growth rate on the order of 50 to 60% for lithium-ion within stationary storage. So what happened here? You know, we always hear about battery breakthroughs and fundamentally new chemistries. Why are they not quite yet making an impact? And part of that comes back to the same point as the previous part of the presentation. It's the very, very aggressive cost curve where we look at dollar per kilowatt hour here. This is shown for EV pack prices. So this will be different when you package the system for stationary installation. But nonetheless, you can get a feel for the really quite aggressive cost decline that we've already seen and will continue to see. Now, to get a little bit more granular here, there's definitely some hotspots of activity where some countries have taken an early lead in terms of developing experience with deploying these systems. So in aggregate, we're seeing Japan, US, and Germany as kind of the three biggest markets for stationary energy storage in terms of getting up deployment expertise. Also up there, we see activity from South Korea, from China, from Canada, and a few other select geographies. Things that really help here, having a very innovative local industry, having strong policy support, having subsidies, and just kind of the pressure, the gentle push from the overall government perspective to experiment with these technologies. In terms of companies to watch, so this is a breakdown of the companies that are getting the most commercial traction in deploying stationary storage. On the power side, we're seeing tremendous work by BYD out of China, as well as Samsung SDI, Saft, who I actually saw us displaying a booth here, LG Chem, and formerly known as A123 Systems, now bought by NEC in Japan. So these are some of the key companies that today define the landscape as having the most experience, the most track record, and kind of any newcomers to the industry will have to butt heads with these companies for market share. Breaking down the same numbers, not so much by player, but by industry, we see that a vast majority of projects, so about 60 to 70% of the projects, are deployed in utility scale applications. That's then followed by commercial and industrial. Residential is something where we're seeing a lot of excitement, but so far it's still, the economics don't quite add up there for the average consumer. So to finish this off, I wanted to present some of the things that we're seeing in terms of case studies for the mining industry, some trends to be aware of. So projects like this that are going into the ground now, we think are tremendously interesting over the coming years to consider as doing plus energy storage. So this is a project in 2016 that was done in Queensland by Rio Tinto with First Solar. So they're deploying distributed ground-mounted solar power So they're putting in about 1.7 megawatts of total solar capacity. That supplies about 20% of the energy for that particular site. And they're looking at saving about 600,000 liters of diesel per year. We think that this is a pretty fine first measure, but fast forward 2 years, 4 years, this is prime opportunity to pair this with energy storage to enable that percent of supply energy to be higher and enable that fuel savings to be even greater. Now, also in Australia, and I want to highlight Australia here because they're doing a lot of innovative work around deploying energy storage. This is a case study done by an Australian utility called AGL working with Sunverge. So they're deploying about 5 megawatts of batteries. And what's unique about this particular deployment is they're using something called VPP. That is a virtual power plant. So they are aggregating 1,000 separate assets into an overall capacity that can then provide services not just for the end consumer, whether that's a residential consumer or a commercial industrial consumer, but it can provide services back to the utility so that the battery has multiple revenue streams. There's the on-site benefits, where you might be saving fuel, but there's also the revenue stream by providing things like frequency regulation or peak demand reduction for the main grid. So for applications where the asset is grid connected, this concept of VPP is, in our view, really going to emerge as an interesting new revenue stream over the next decade. Now, there's a lot of work to be done in terms of market mechanisms and recognizing that and the real economics around that. So we do think it's going to take 5 to 10 years to really bring this technology to maturity, but it's one of the things that will do really interesting things for the economics of energy storage. And that kind of ties this into the broader evolution of the grid as a whole. So for a long time, the incumbent centralized grid, you know this picture, it goes from generation, transmission, distribution, and power retail. And as we talk about kind of this brave new world over here, certainly we have the topic that we're talking about today about energy storage and how do we pair that with generation, whether that's solar or wind or diesel. There's the power electronics component that goes into it, but a lot of work being done around software and connectivity, systems integration, and these two acronyms. So I mentioned VPP, virtual power plants, but also DERMS, so distributed energy resource management systems. So in our research, we've seen a huge amount of innovation that is happening in VPP and DERMS. And it's all connected, and these kind of abilities can really affect the economics of the fundamental energy storage itself. So in our perspective, we're increasingly excited that what will bring energy storage to a mass market and really make it affordable for everybody might not necessarily be, you know, a new wonder electrolyte in a flow battery. It might be more to do with the clever work that is being done here on the software integration and market mechanism side. And finally, I also wanted to kind of leave you with some of our findings around companies that we believe are ahead of the pack here in terms of thinking about how to apply energy storage to new installations, particularly around distributed generation. So what this analysis that we did ranked companies on is business execution on one axis and then technical value of the solution on the other axis. And you can see that over here, essentially, we've got 4 types of companies that are all vying for the same customers, trying to solve the same problems. So we've certainly got a lot of startups in energy storage, companies like Greensmith Energy, Green Charge Networks, Sonnen, NSYNC Energy, and so forth. We've got large industrial conglomerates, like, for example, Eaton, Siemens, General Electric, Toshiba, Panasonic. Then we've got some more specialized developers and installers. So here, looking at companies like Solar City, which is now under the umbrella of Tesla, Sunrun, Vivint, SunPower. And then you've also got IT and kind of home automation, companies that so far are not really making much of an impact, but they are interested in how can they contribute more to the space, like, for example, IBM, Google, Cisco. And what we've seen in our research is that the best positioned companies make some pretty strong partnerships. And so we're talking about companies like SunPower working with STEM, Solar City and Tesla, Panasonic, ABB and Samsung SDI. So to wrap up, I wanted to finish off with kind of 3 closing thoughts around some of the things that we see as important for the future of stationary storage and how it applies to industries like mining. So one of them is that we firmly do believe that energy storage is undergoing a breakthrough. It's a very gradual, very subtle breakthrough. It's easy to miss, and it's not really due to fundamentally new technology. I would love to see new technology, and I know we've got some startups here that are working on ways to kill the lithium-ion battery for particular applications, and I would love for that to happen. That being said, even if it's incremental lithium-ion battery innovation, that's also not a bad thing. There's a lot of cost reduction still left in that system. So expect projects that before, you would have had to pay $1,500 per kilowatt hour or more, starting to make sense once we get to levels like 500 or 250 post 2020. Stability of the company matters a lot. Like I talked about, Panasonic, LG Chem, BYD, Samsung SDI, and others are kind of defining the landscape as you see it today. And these companies are putting billions of dollars into new production capacities. They've got a lot of projects in the ground. They're starting to get expertise around how to operate, manage these systems, warranties, and so forth. And so for outsiders breaking into the space, competing with these companies is going to be a pretty serious challenge. And then third, as we've seen most recently with the Samsung Galaxy Note 7 disaster, just because something works really well in an EV or a phone does not mean that when you have a remote mining site that is fly in and fly out, that's also the optimal solution. So there certainly are shared technologies, but there's an industry, kind of a niche industry that is spinning up where we focus on companies that are really looking at high durability, custom-built cells for particular applications that have much higher performance, safety, and other kind of envelopes, particular for the application. Great. And so with that, thank you very much for your attention.